Look, we all love the International Space Station. It's inspired so many people, but it's on its last legs. You know, all this doom and gloom, it's gonna burn up, it's gonna be destroyed. Should we save it? Should we make it a museum? What I wanna know is who's gonna build the next one. That's why we're here today at VAST in Long Beach, California, to see what they're up to, building space stations. We've been invited to tour their factory to see actual space station hardware and the people and machines that build it. Let's get inside. But you know the drill, I don't know everything about VAST, so I've got somebody here to help me explain everything. Max Haot, how are you doing?
I'm great. Thanks for being at our headquarters here today.
Thanks for having us. You're well qualified to tell us what VAST is up to, aren't you?
I think so.
A little bit, you're the CEO.
Yeah.
All right, tell us about what's going on. I mean, I see a space station, but I also see a capsule that I recognize here.
Our Dragon capsule from our friend, the only way to go to a space station if you're an American company. So,
right.
And also the best way. So yeah, to take a step back, VAST was founded in 2021 by our founder and sole investor, Jet McCaleb. I joined through the acquisition of Launcher in 2023, I guess, in February 23. So I've been here for about a year and a half. So if you look at the inception of VAST, we're a space station company. So obviously our goal is to build the world's best or the universe's best space station.
I like it, the universe best?
Well, I guess so, right? Or the known universe, I guess. And then, in the early years, we established a long-term roadmap, which is we want to be the company that makes artificial gravity space station a reality.
I like it.
We all know that what it looks like in science fiction. But the basics is that if you create a big enough wheel or a stick in our case, assembling 6 Starship launch module, we can create a structure that's 105 meter long by 7 meter diameter cylinder. And if we rotate it at 4 rotations per minute, we get 1G on either end, microgravity in the middle, and then Moon and Mars gravity at different
different levels of the stick. So instead of just one wheel where you have a set gravity, or I guess force
at
the
rim, spokes, you could still have that. But there it's also simpler to build than a wheel. And obviously the Starship era will make that a lot more realistic that we could build this, right?
Yeah.
And so that's a long-term vision, and the reason we want to do it is we obviously believe in a world where we are multiplanetary, where we have people on Mars and the Moon, but also have more people living off Earth than on Earth. And for that to happen, we think an important part of the architecture is also to have artificial gravity space station, so people can stay indefinite, live full lifetime in space. Right now, we don't know, humanity doesn't know whether we know 1G works for a lifetime. We know 0G doesn't. Bone loss, other ailment, muscle loss. Is very difficult for professional astronauts when, after 6 months to a year when they come back. But we don't actually know if Moon or Mars gravity will be enough.
How that affects you long term.
Well, the thesis is that, maybe Moon gravity will be enough to live a full lifetime, right? Maybe that resolves it. So a platform where we can test that for humanity and then go from there and build even bigger space station is our, vision. So, as you probably know, there's a few companies that are competing to be, America's next space station or the world's next space station.
The universes.
The universe in this case. Our view is that none of us are actual space station company. I don't have right now a space station on orbit. I've not had a crew go to it and come back. Neither have any of our competitors. The only space stations that have been created are government programs, and there's never been a commercial space station.
Right.
So VAST view, while we have this long-term vision, we're also a very realistic company. And so if we want to create this amazing future, we need to exist. To exist, we need to be profitable. And so to be profitable, we believe we need NASA as an anchor customer. And then we want to secure, obviously, international space agencies as our other customers and private individual, not tourists, by the way, private individual that are involved in important space exploration mission. So that's a big opportunity that exists in the space station market, is the opportunity to have NASA select us to be the replacement to the ISS. That's expected to be selected in mid-26. So VAST is all in on winning that. Like if we don't win it, we don't think we can even exist. So it's a matter of survival.
Okay.
And then back to stepping stone and being realistic. Like how can we win? So we decided to compete for it only early last year, in May last year. And NASA had already worked with some of our competitors since 2021 on a CLD phase 1 contract. Now, these contracts are not to build an actual space station and launch it. It's mostly to do paper design and be ready to to bid this bigger contract.
Like show that you have the ability to even do the plan to make the space station
have the team
happen.
and so on. So,
Right.
but not actually do the proof that you can do it, which is build a space station, launch it, and have a crew visit it. So we arrived late, right? NASA didn't even know who we were last year, and we were, okay, how can we leapfrog and make sure we win? And the strategy we came up with is, back to the model here, is Haven-1. So our thesis is, what if we actually build a space station, launch it on orbit, have a crew of 4 go to it 3 months later with a Dragon,
Yep.
spend 2 weeks at least in the space station and come back home safely? What if we did all of that before NASA and the US government is to make a decision? We believe that if we execute it all by mid-26, we will be the world's first commercial space station. We don't think any of our competitors have any shot to have achieved this milestone that I've described. We'll obviously be a space station company at that point, and as a result, we think we'll be the clear choice to win or be one of 2 winners.
It buys down a lot of risk if you've already got a space station that you've successfully launched, that's already there, that's had crew go to it. That proves a lot of things instead of leaving it as a question. Can they do
everything.
it?
You are an actual space station
Yep,
company.
yep.
The other piece you'll see if you look at our Haven-2 architecture. So Haven-1 is this MVP, minimum viable product space station, trying to make it as simple as we can. It's, unfortunately, space station can't be as simple as well, it can be as simple as we can, but it's never very simple.
Yeah, it looks like a one-shot thing. I'm used to the ISS, which has all these modules and is assembled over hundreds of launches and all connected together. This is sort of one piece that you can do in one launch.
It will be the largest payload by volume ever launched on a Falcon 9 reusable.
Okay.
It has, as you can see, 1 docking port, a window, and a livable volume, which is about 6 times when you dock it with a Dragon. The crew will have 6 times more space than if they just had Dragon. So it's a livable space, right? Like, so they have sleeping quarters, they have obviously a crew common area, they have the window, they have payload, and so on. But the point is, we try to keep it as simple as possible. So 1 module is obviously a lot simpler than 2 or 3 modules. If you look at the history of space station, even Salyut in the Soviet program, it all started with a single module space station, and then you grow from there. So for Haven-1, because our priority is speed, and actually our priority is safety.
Making it actually exist in orbit.
Yeah. So we try to keep it as simple as possible. So 1 docking port, and then we decided that it should be designed for 3 years on orbit, not 10 or 20 years.
Right.
That's a simpler approach. And then we decided also that we would rely on Dragon as much as we could for life support system. So that means that, for example, one of the key life support system is the CO2 scrubber.
Right.
And Dragon basically has a cartridge that the crew, on Polaris Dawn, Inspiration 4, or even going to the ISS, every day they swap that cartridge with a new one. And Dragon is limited to 4 or 5 day max for a free flyer. So in our case, SpaceX is manufacturing this cartridge for us, 40 of them. And they are flying with Haven-1. So when the crew arrive, they are available to basically put in the Dragon mechanism.
It's like a consumable, but you've got extra cargo storage. It'll be there for them to use already on your station.
Exactly. Back to the design, that ended up being sort of mass and volume constraint. So Haven-1 can have 40 days of crew time during its 3-year lifetime for 4 people. And so ideally, we launch Haven-1, and then 3 months later, the first crew goes there for 2 weeks, or 10 days on the station, 2 weeks if you include the transfer. And then over the 3 years, we expect to have 3 additional missions, every 6 to 9 months in between. And then at the end of the 3 years, so 2026, 27, 28, towards the end of 28, we will deorbit it under its own propulsion. And by that time, we will have Haven-2. The whole point of explaining this is that what you'll see today is all of these subsystems, the manufacturing testing capability, all the subsystems we are building, and then we were talking about Haven-2, which is our ISS. So this is not the ISS replacement. Right. Haven-2 will actually be made of modules. Some module built on and launched on Starship. Some module are derivative of Haven-1, longer with 2 docking ports, NASA certified, and launched on Falcon Heavy with a stretch fairing.
With a stretch fairing.
But the point is that, other than demonstrating to the world that we can actually build a space station, and to NASA, what we're also doing is developing all of our technologies. How do we build primary structure? How do we build CMG? How do we build avionics? How do we build thermal control system? And Haven-1, you can see all of these technology that we will have proven on orbit are all going directly into Haven-2 Module 1. So by the time NASA has to pick a winner, not only do we expect them to have to be able to see our performance on orbit, but each of the subsystems that are on Haven-2 will have heritage, on Haven-1.
Yeah.
And so that should bring confidence that we can do it quickly.
All right.
All right, let's see some stuff.
There's so many things. There's so many things I want to ask, but we're going to go actually see it now.
Okay. So we're going to start with this building. We have 3 buildings on campus, 150,000 square feet. We also have another building near SpaceX in Hawthorne with our additive manufacturing. And we have a test site in Mojave. We purchased the Virgin Orbit X test site where we can do propulsion, but also pressure and load testing for our primary structure.
Okay.
So here we're in one of our 3 buildings in Long Beach at our campus. And this is where we manufacture a lot of the sub-assemblies. All of our team is all over there, designing it. We do all the testing, thermal and vibe testing, and the integration of these sub-assemblies. And we also manufacture with our machine shop here. So we're going to go and see loads of pieces of Haven-1 in process of design, testing, manufacturing. And then when we're done here, we'll go to our headquarter building, which is in construction, and look at the primary structure of Haven-1.
Excellent. So most of this, it's not like you make a part and then you have to ship it off, and 2 months later the testing's done, then it comes back to you. You're doing most of it here yourself, right?
Yeah, so you'll see. So for example, here, this is the thermal lab.
Yeah.
There you can see a vacuum chamber. So, for every piece of hardware you make, you have to do, thermal testing, and you also have to do vibe testing.
Yeah.
Smaller companies will go out of house, but we do it all the time, 7 days a week, because we have so many components that are either being tested on Rev 1 or being ATP to go on flight, right, and everything in between.
Yeah.
So it's key. You cannot succeed at going at the speed we are going without having in-house testing. So this is one of the facility called the thermal lab.
Where you can, no kidding.
This is actually we'll go inside. This is our avionics lab, and there you can see we make the batteries in-house. You can see our batteries. This is a version for our demo satellite called Haven Demo, which we are launching in April on a SpaceX bandwagon mission. And the Haven-1 batteries are just bigger, scaled up version of it.
Right.
But we'll go and look at it. But we do everything in-house. We screen the cells. We obviously don't make the cells, but we screen them.
Sure.
We put them in these enclosure, we put epoxy, we have PCBs, we wire bond them with this machine, and so the whole process is in-house. So you can see one of the test assemblies.
It's like a stack, like two modules stacked together.
2 batteries for Haven Demo.
Right.
And the Haven-1 batteries are even bigger than the whole tray there. So this is a prototype. We've revealed what Haven-1 will look like inside in November. And one of the key, you see a lot, so you can see this payload, and you can see like there was a trash can there for the wet trash. But usually when space station companies or aspiring space station company put out these renders, it's just an artist's illustration.
Right.
This is the actual design, right? So it's the actual design of Haven-1 from the engineering team with the actual material. It's obviously a render, but it will look like this.
It'll look like this, like based on what you're building, not what it might be.
Yeah, like it's
not
not like the
brainstorming,
marketing
it's what you're
department.
making.
It's what we're making. So, we've put a lot of thought into design, not because we're building a hotel in space, but we believe that high design can help with, you sleep better, you have better crew cohesion, communication, and so we believe it helps with the primary mission objective to have a great living environment.
We want people to be able to live and work in space and making them comfortable in human comforts.
Yeah, as much as we can. Yeah. So if you remember, we were talking about CMGs. So you see this device, and I don't know if you can hear it.
Yeah.
The blue one at the back were the first generation, the gold one or the third generation. And so these are the CMGs. So inside there is a piece of metal. I forgot the exact mass, but it's
mass. It's spinning in
there. It's very heavy.
Yeah.
Good bodybuilding kind of apparatus that's spinning at 5,000 rotation per minute.
Right.
And they'll be spinning for 3 years. There'll be 6 of them on Haven-1. And these are gigantic reaction wheels. So obviously when we move it, instead of just the wheel moving, the station moves.
The station moves.
And so it allows us to keep the solar array pointed in the sun and keep the attitude of Haven-1 without using the prop.
Yep.
And obviously it's using electricity, which is unlimited.
You can get
because
more
it
of that because you have
regenerates
solar
all the
panels.
time.
Yeah, that's the huge thing with the CMGs. If you have thrusters that are, to
Yeah.
keep your station
Yeah.
oriented the way you want, you're consuming fuel.
Yep.
So then you have to resupply it. You have to store it. How big are the tanks? When you use something like this, you're just using the free. I say free power from
Yep.
the sun. The free power from the sun, and you speed them up, slow them down, move them. You know the bicycle wheel experiment, right? Where the physics teacher is sitting in the spinny chair moving the bicycle. It's the same thing.
That's the same
But you're making these.
physics. Yep. And they've been running for more than a year and a half, billions of revolution. You know, it's quite complex with bearings and cooling. And so we build enough confidence that we can fly them, obviously. And it's a usually long lead time. And I don't think any of our competitors have succeeded at this yet.
No kidding.
And that's a very important element if you want to build space station. So now we can enter our component department.
Okay.
Actually, we were talking about the design was real, and you can see in the design they show the crew opening one of our wet trash can. So that's the prototype of it.
This is a prototype trash can?
Yeah, this is a trash can. I forget the exact number. We have maybe 5 or 6 on Haven-1.
Right.
Because Haven-1 is a consumable-based life support system, but also we don't have any cargo capability or we're not jettisoning trash. So everything for the 40 days of crew time over the 3 years has to stay inside.
Okay.
And so this is for wet trash. And so we have enough, for all the consumable, we have enough volume to store all of the wet trash for the whole mission.
So it doesn't come and go with the Dragon. The wet trash stays on station.
It's because there's limited
Cargo capacity.
Cargo mass and capacity and volume. But what happens is that it's actually a pressure vessel, and it gets exposed to the vacuum of space. So it's stored in vacuum.
Okay.
And this is why it's in this department, which does a lot of the pressure system. This is actually the Haven-1 hatch. And so this hatch, obviously we had to design it in-house, machine it in-house, testing it in-house. This is the actual one we will be mounting next week to our primary structure for the qualification test.
Right.
And the way it works, I guess you can see, you can crank it. And we can open it. And here we go. That's what the crew will do, and we'll enter Haven-1. So
this is actually going for qualification
That's
testing.
for
This isn't like
qualification,
a
and
demo that we show the tourists.
and this is there's to seal and so on. And then it's not the flight one. The flight one is in manufacturing right now.
Sure.
And then obviously you can close it when you leave Haven-1 and stow it.
Does it have like an indicator or a red light that appears, or is it in the middle?
There is this pin right there that when it's saved, it's flush.
Pops out like
it's flush
that.
there. And there's actually labels that explain that are not on this article. As I mentioned, this is our component department, and one of the key components for any spacecraft or space station are valves.
Valves.
The joke is that spacecrafts are valves, right? Like that's really what they are. And back to the market for space station valve, they need to be compatible with crew system safety. There's a lot of standards that are much higher rigor than
For human rating versus
for human rating.
Yep.
And also have to they are designed for a specific function. So for example, this is the pressure relief valve. That's actually the one for Haven-1. That if there's too much pressure in the cabin, automatically release it to the vacuum of space. And you want to design it the exact flow rate, the exact pressure, the exact orifice size. So it's obviously our own design that this team has designed, manufactured, and testing. These are thermal control fluid mixing valve, like you can think of your shower where you can mix the cold and the hot.
The cold and the hot, okay.
And so we have one design that's based on on a wax kind of principle where it's at a set temperature and it mixes it at that temperature. And then we have a new design which is based on an electric actuator, and so we can really set the cabin temperature and control it. So that's kind of new. I don't think that's been done on a space station or a spacecraft. This is our oxygen tray. These are solenoid valve. We make them in-house, so we machine them in-house. We do the coil, we do the potting and the testing. And these are dispensing the oxygen and the nitrox from the tank to the cabin as needed by the control system.
And it's the whole thing. You wind your own coils, you said?
Yes. Right there, the machine is behind there. So yeah, we test them, we wind. You can see that's the coil winding machine. They're not using it now, but
Yeah,
you know,
it's just
wind
right
the
there.
coal.
It looks like a lathe. I guess that makes sense.
We'll see later. That's not the actual one. Impulse is making these, carbon overwrap
Yeah, the
tanks.
COPV.
COPVs. Was trying to be friendly to your audience, but they
That's
know what
fine.
it is.
Yeah, you're right. I just did a video explaining all the acronyms, and that was one of the
Check
acronyms.
the video. This is a mock-up. This is not an actual COPV, but we have about 12 of them around the part of Haven-1 that necks down to from 3.8 meter to 2.8.
Right.
And over it, we have MMOD shielding. So when you look at the render, you cannot see it. But when you look at the primary structure, you'll see that it necks down so that we can fit them all.
You have
so
room on the external of the pressure
all
vessel,
around,
I guess.
And this is for the propellant, so the nitrous oxide and the ethane gas propellant, and then for the life support consumable, oxygen and nitrox.
Right. It's got like a heating element or something, like a resistive heating element.
You have to, it's a gas stored as a liquid, nitrous oxide.
Right.
And so if you want a set temperature for example, your thrusters and so on, so it's set pressure, you use temperature to control that.
To control it, makes sense.
So this is our avionics lab. We make harnesses there, we make batteries, we make flight computers and so on. We're approaching some of the things in the queue of our quality department.
Right.
This panel probably will be flying, and we'll go through that a bit more later. So this is one of our first sub-assembly clean room. Actually, you can see the actual flight COPV right
And
there.
on the table back there.
And this is actually our program called Haven Demo. So Haven Demo is a 500 kilogram satellite that's flying on Bandwagon 3 next year on the SpaceX rideshare. And it's designed to test all of our propulsion, avionics, RF systems,
all the subsystems for...
nothing crude, so
right.
no pressurized element to there, but everything that's avionics and propulsion is being tested on this mission. And it cost us single-digit millions, maybe a $10 million program.
Sure.
While Haven-1, by the time we fly it, we will have invested $1 billion. So you definitely want to test as much as you can before the day we are looking at this space station on top of a Falcon 9.
So it's not just you're trying to do everything perfectly in one shot. We're going to do this huge monolithic space station. We only have one shot. Like, you're testing things in advance. You're actually sending it to space to see how it works. Then you'll use those systems on the first Haven-1 module.
It's a validation. They are all, the flight computer, the software, the radios, even the camera there at the top. There's a camera.
I see a camera.
And then on the propulsion side, we don't have all of the tank, but you can see we have one of the COPV, which is on the side. It will go inside. And then we have an ethane tank there that has some MLI in silver there.
Yep.
And these are the panels that are going on the side. So this is our clean room. We are doing integration.
That's sort of the cube there that's on the center table, the blue thing. That's
it.
The actual setup?
Yeah, well, we'll have the panels on the side and many more things integrated with it.
The COPV will go in it, the panels go on.
You
like
get
that's
the idea.
the actual
that's
flight.
the one going, that's the flight one, yeah. We're flying in a few months. So.
It seems like such a good idea. Like you've heard of companies that try to, we're going to simulate everything and then fly at once. Well, get it out there and test it.
Well, there used to be a point where, if you wanted to get a rideshare, it was very complicated and not very available, but SpaceX launched this rideshare program. And now, it's affordable, but also available.
Right.
And so it makes a lot of sense that to de-risk, you would fly a small satellite before flying your full system.
Yeah.
I think we'll see a lot more of that in the future. It has not been the case because it was just too complicated to get a rideshare mission.
Right. It's got some schedule availability too. It's not like, we have to plan this and 10 years from now we'll be able to fly this test. The cadence really helps with that testing.
Yeah, and we have 3 slots on 3 different missions. So, if we have a problem with it, we can fly quickly a few months later, the second unit. So just an iterative way of working. And we obviously do an incredible amount of testing on the ground, hardware in the loop testing and all of the environmental testing. But this is just one extra validation. And it's also great training for mission ops team and our ground segment. For the ground segment and to some extent the software and the mission ops team, it's sort of, it's not that different than Haven-1. Haven-1 is a lot bigger, but they can validate a lot of systems.
The process is the experience, just the team working together to operate that mission.
Yeah, LEOP, the early stage of finding your satellite and communicating with it and so on.
Yep.
So this is our first primary structure we built. It's about 40% of Haven-1.
Okay.
And we can go check it
We can
out.
go up here. All right.
And so the story is that when we started the Haven-1 program, right, we announced it in May last year. So
Yeah.
it's a little bit about a year and a half from today, right, ago. And we looked at outsourcing primary structure, we couldn't. And we then started with stainless steel as our primary structure.
Okay.
But unfortunately, we didn't make as much progress as we wanted. So at about November, we decided to dual path aluminum. So this is aluminum 2219.
Right.
And we dual pathed it, and we did both in parallel. And then in February this year, we decided to select aluminum, and we went and did it.
So that was November of last year, 2023,
when
I guess.
we started the
when
capability.
you started with it.
And in February, we stopped the work on stainless steel and moved the team to aluminum.
Like all in on aluminum, I guess you could say.
And so this is the first object we created, the Pathfinder for primary structure, to prove to ourselves that we could create the panel, we could form them, we could create the weld using the plasma technology we use, and all the different pieces, and integrate with the hatch. So from a volume point of view, this would be the corridor where the sleeping berth are,
Right.
and the crew enters. And then this is the sort of 3.8 meter space you have for the common crew area.
Right.
The payloads are towards the end. But this is not the whole thing. But you'll see it next
this
door.
is
It
like
goes
half,
all the way,
right.
a little bit even less than half.
But here you were making this, you're taking the aluminum, you're CNCing it. Do you call it isogrid? What do you call your grid?
This is orthogrid.
Is it orthogrid?
ISO is a triangle.
Is a triangle, this is orthogrid. So you're able to do that, you're able to weld it together. Like this was the first, not foray, I guess, but proving that you could do these things and it would work for building the full structure.
Yeah, we were confident we were able to do this, this diameter reduction. You'll observe that we have the orthogrid on the inside. We were trading inside, outside. We ended up on the outside on the real one.
On the real
so
one?
there's it's when you have it in-house and vertically integrated, you can iterate really quickly. So it takes us one panel. You can see there's 1, 2, 3, 4 panel to this ring.
Yeah.
It takes us 1 day to CNC one panel. And we have 6 gantries. So we can make 6 panel every day.
So 1.5, because it's 4, so 6 is 1 ring plus the half of a next ring. in
Yeah,
one day.
exactly.
Yeah, 6.
So that's just not a bottleneck. So and you'll see next door for the next vehicle we created, the qualification one, we actually made 3 sets of every panel. And so that we have all of this extra hardware that if we have an issue, we need to replace a ring or make another one, or an issue in welding, we're ready to go. So we are able to do at that speed. And obviously right now the bottleneck is welding and inspection, and we're kind of improving that really quickly.
Excellent. I say it feels spacious. I haven't been in very many space stations, I guess, but having been in...
What's unique is that on the ISS, everything is about 4 meter, but they put racks all around. So you never have access to the skin.
Right.
And so in our design, you have, you can see on the render, you have a corridor area, a hallway, where it's smaller, but then for the common area, we make it full diameter, 3.8 meter. And that's probably bigger than any room on the ISS there. So this is another clean room, and what you'll see right there is a lot of our responsible engineer testing and working on various subsystems, mostly life support.
This all looks like a life support exchange or something.
Yeah, this is a air revitalization test setup basically. And then there's many other test stands right behind.
Space station HVAC.
You can see, every single piece of assembly that will go on Haven-1 will get integrated in there, and then the final integration is next door.
And once again, it's here in-house. Like it gets made there, it gets right over here. They test it. They make like it's not shipping off, and weeks later it comes back. It's all right here.
We'll see our quality department. This is our supply chain inventory department that's actually moving to that building soon, and we're expanding the machine shop. These are panels that I believe are going to space as part of our flight unit.
Okay.
So they arrive as raw material. We then water jet them into the right shape, just here. And then these gantry right here, we'll go and check one out, are running basically a day later. They are ready to be inspected, and then they get rolled and then welded. So this is our machine shop. We're going to check it out. Get some glasses. So look at some parts that are in progress. These are, for example, Avionics enclosure that we make in-house. This is an interesting machine.
Look at this.
That's a fixture. It's a 5-axis CNC machine.
Right.
So our philosophy is that actually we ask our team, the core of VAST are the responsible engineers.
Right.
They are responsible for a subsystem, and then we empower them to deliver their system. And so one of the things we do is we tell them, if you can outsource to the supply chain, machine shops and so on, you should do it so you don't bottleneck our own internal department.
Yep.
And only go in-house if you need a quicker timeline or it's a complex part and you need to work quickly. Now, one of the examples of large format CNC, you can see this part is about 1.5 meter diameter.
Sure.
That in the supply chain for using a machine like that will probably take 6 months before we get the part. We knock them out in 3 or 4 days. So that's a real key asset. When you go to smaller parts, then you can use a supply chain more, 3-axis small part or 5-axis small part. It's pretty quick. You can get them in weeks, but here we can get them in days, right? Or even in the same day.
That's a huge difference between having to order it and wait for it and that sort of stuff. You're just right here.
So we run 2 shifts from about 6 a.m. to 2 a.m., 6 days a week. I don't know where Adam is. Yeah, that's a 5-axis. They're just about to get started with whatever they're doing on it. Different brackets. I think we're just at lunchtime.
Yeah, that's a perfect time for us to go through.
Yeah, we picked lunchtime, which is not ideal, but let's keep going.
The interesting thing is these machines are all clearly in use. They're not here sitting, not being used. They've got chips everywhere because they've been making parts.
Yeah, of course. So these are lathes. So that's the part they're making. Let's go this way.
Can you keep up, D? We talk about like it's an active facility.
Just finished, but this is actually the vacuum table, and this is one of the panel. So these are the 6 machines we were talking about.
Right.
There's one back there, 1, 2, 3, 4, 5, 6.
Right.
Where we make all of the panels. So raw material comes in, we water jet it, we mill it, and then you'll see what happened next door. We roll it and then weld it.
Gotcha.
All right, let's keep going.
So you're cutting out like the basic structure with the water jet, and then you take out the excess material for the orthogrid with these machines.
Yeah, that's
saving mass, I guess, right?
The basic principle. There you go. So a few more test stands. RF testing chamber, very useful. Another facility that you need to do a lot of testing with our radios and our antenna, or EMI testing we can do in-house.
It's just here.
It's just here. All right, so let's look at a few cool things here.
A few cool things. What do you think we've been looking at so far?
So this is the actual qualification window.
Right.
You'll see on the primary structure where it mounts. If you want, you can go underneath.
I could go underneath it?
Yeah, and you can look through it. So this is actually the pressure layer. In space, there's actually will be 2 extra layers.
Yeah.
So that we have a micrometeoroid shielding. You can get a sense of what people will be able to see on Haven-1.
It's not just, I say just a dome, it fits the curve. So the actual dome.
The final design of Haven-1 is on the side. We've updated all the render.
Yeah.
And you can see how so this one doesn't have the 2 extra layers.
Right.
For micrometeoroid, and this is actually a test where we prove that 2 layers is enough for micrometeoroid testing. So this didn't puncture, and we'll have 3 layers basically.
You'll have 3 layers. And there's one behind it.
Well, this is actually, we'll look at this. This is a test of micrometeoroid shielding, not for the window, but for everything else.
Everything else, yeah.
So you have 3 layers. This represents the pressure pane of Haven-1.
Right.
The first Whipple shield, and then the composite material. And we fired on this a 6.4 kilometer per second.
Kilometers per second?
Projectile, and we proved that it didn't puncture.
It didn't
the
puncture.
pressure, the thing. And so we've done hundreds of these tests. And you can see here the architecture of it. So this is actually what you'll see next door.
Oh.
What you see next door is Haven-1. It's full of this grid pattern.
Yep.
But in the final integration, we're mounting this composite material
Yep.
and this aluminum layer.
Yep.
And so that's our micrometeorite strategy.
just
you
about-
can look at it on the side if you want.
Like dispersing the energy, right? You have the initial one, then you have the composite that almost, it like shreds.
Yep.
If you look
and we
at
have
the
a
test
cool
over
video
there.
we can send you that you
Yeah.
can get a sense of how that works.
And all that's to get rid of the energy before it hits your actual pressure vessel, the third.
So the whole of Haven-1 outside will be like this. And so back to testing facility. Hey guys, this is our in-house vibe lab. So this is our vibe table where the 500 kilogram Haven demo satellite can be tested there in-house.
Right.
Right now they're doing vibe testing or ATP actually of the flight unit of the batteries for Haven-1. You can see right there at the top.
Uh-huh.
And there we have actually another vibe table with a star camera, in-house developed star camera that will fly
Like
both
a
on
positioning
Haven-1.
tracking camera to.
Well, it looks at the star and it tells you your attitude,
Yep.
basically. So this is our own design that will fly on Haven Demo and Haven-1, as well as other systems for redundancy. All right, so yeah, let's keep going. Couple
All right.
more, and then we'll go next door.
I mean, you could really see how much this helps you keep the pace going, right? We're not having to visit 8 different facilities all scattered around the country. Like, we're literally walking from the place that it's made to the place that it's tested, the place that's like everything is
Yep.
right here within
And
walking
more
distance.
importantly, the place that it's designed. So I'll
Yeah.
show you up there.
We haven't even
where-
changed buildings yet.
Yes, that's right.
It's all in one building.
But more interestingly, like last September, we actually won a contract with NASA called CCSC2,
Right.
where they are monitoring and helping us technically for Haven-1. And they came here for the kickoff in September last year,
Right?
and everything was empty. There was nothing. So it was pretty hard to convince them that we were going to do this. But you know, they come every quarter, they keep following progress, and the
Yeah.
pace at which we move is, I think, the part that they are most impressed with at this moment. Hey, Colin.
I mean, it's almost like the building is being built as the same time the space station
You,
parts
you
are being
should have
built.
come earlier. Yes. So this is
Here,
our.
D, I'll let you through.
Hey guys.
You good?
So this is a very important department. It's a piece of our quality in department. So
Right.
this is a CMM this is a machine part that we are inspecting.
Yeah.
Inspecting other parts. Right there, different panels for Haven Demo. And so every part we manufacture is going through this department to make sure that it conforms with all of the dimension and all the spec.
Yeah.
And then for human spaceflight, we have a full process with traceability, so that from the material coming in to everything that happened to it being installed on the vehicle and the work order, you need full traceability
To
and
know
all
exactly.
the way back to the vendor and where this material came from.
Yep.
So this is one of the many steps in that process. So,
I love these granite tables, like the ultra flat
yep, that's
test surfaces.
can't inspect without it.
I got it. Go ahead.
Okay.
Good.
Oh, Drew,
Galloway tell you what he wants.
you want to be on
Catch
video?
up with Max
really.
here.
Yeah, come on. This is Drew.
How's it going, guys?
Hey, how's it going?
Yeah.
Nice to
Drew
meet you.
is
I'm
our
John.
astronaut advisor
Right.
that's helping us design Haven-1
Yeah.
and many other things. So
Excellent. It's good to
Das
meet you.
is from
Yeah,
NASA
good to meet you as well.
Spaceflight,
Thanks
and
for
we're
coming
doing
out.
a full walkthrough. So
Yeah. All right, well, we cleaned the place up for you a little bit.
It looks active. It looks like you're getting stuff done.
Drew helped desigin the sleep apparatus. You want to try it?
Do I want to try it?
Yes. So
What do I do?
That's the.
So you step in.
We might need Dolly to
I think we've prepped for it.
Like
watch your step.
out this way?
Yep. And then there's little slots for your arms if you want it.
Slots for, where's the slots for my arms?
Right there.
Okay.
And hold on. Now we're inflating you.
It is. It like pushes you down. It pushes you back against the surface,
Yeah. So Haven-1 has 4 sleeping berths,
right?
and then the crew will each get one of these. And so you can see the difference between a free flyer Dragon mission, where
Yeah.
everybody's trying to sleep in their seats or floating around, with the comfort of Haven-1.
It's so instead of having a strap that has like a pressure point that's like strapping me to the wall or whatever, this is like putting force on my entire body and sort of holding me down almost like gravity? Is that like the plan? That's the idea? No, because I could see like if I was strapped in, or you see a sleeping bag or something like that, maybe it cocoons you in, but it's not really giving you the pressure that a blanket, that is really cool.
Exactly.
So
I'm stuck here now.
we can't wait to try in space. You know, Drew has spent how many days in space?
Enough time.
Enough.
220 some days in space. I know that sleeping can be challenging. In fact, most people that recognize the need for this have slept on the space shuttle.
Right.
The space shuttle is the only place that you can sleep that has these large bags that you can get yourself wedged in between.
Right.
So most folks will
It like
wedge in
constrains
there,
you
and
a little
that's where
bit.
you sleep the best.
It's like building a pillow
Yeah,
fort
so
almost.
That's what we try to do.
That is really cool.
Yeah.
Like one of the many little problems that you have to solve to make people more comfortable if they're actually working in space.
So,
No kidding.
All
Thank
right.
you.
Sleep's important.
let's keep going. Thanks, Drew. See you later.
Appreciate it. Thank you. Nice to meet you.
All right. So you get a sense of where everybody is. So we have 660 or 70 by now team members.
There's people up here.
So yeah, this is where it's all designed. We actually sit there. Yeah, and so there's people everywhere we can put them.
No, it's like, so we were on the factory floor, walking around all the test areas, the electronics and stuff. I didn't know that you had office space up here. It's just raised up to the top
That's
of the
it.
factory.
So here you go. So, hey, Nikki. So let's, yeah, go down. This is a hardware in the loop, avionics testing,
Right.
you know, table. So obviously you want to simulate the mission as much as you can with the hardware in the loop. So that's one of the facilities you need to do that.
You guys just want to grab whatever.
Ah,
Yeah, we're going to go to a construction zone now.
yeah.
So as we mentioned, we have 3 buildings, the one we just came out of. This one is in construction, so we won't go in there today.
Okay.
But this will be the final home of our primary structure department, final home of our inventory department, and our training center.
Right.
So that will be ready in March. This building is our future headquarters.
Right.
2/3 of it we're building our control room and our headquarter facilities as we speak. It should be ready in 3 weeks.
Right.
And 1/3 of it is where we are right now building the primary structure of Haven-1. But that will also be, when that moves to that building, that will be where the final integration is
Gotcha.
when we start with that next year.
I can't even, I mean, the pace that you're at here, where you're still building the buildings at the same time that you're building the flight hardware, it's like you're not waiting, oh, we're going to wait 3 years till our building's done. You got places to be.
Yeah, and you should have, you know, if you had visited us this year, we have, you know, construction where we have people working. I mean, it's been challenging, but everybody is so dedicated to the mission. They
Yeah.
are, you know, flexible, and it allows us to move quickly.
It really is the new way of doing things in space, it seems.
Well, it's maybe the only way.
The only way. There you go.
So it might not look like it, but we're moving in first week of January, and it will be ready. Yeah, right here is actually the middle of our future control room.
Okay.
That will be our control room screen.
Right.
And this will be stadium seating, and our team behind the glass will be able to look
To
at
see.
the control room. So that will be ready at the end of February.
The end of
Yeah,
February?
let's go up.
Are we going up?
Yeah.
Oh, wow.
So, you know, you were talking about the idea that that's one of the areas I like the most, where on this side you have a construction crew
Yeah.
building a control room and headquarters, and on that side you have our team building, putting a finishing touch on our Haven-1 qualification article that's due to ship next week to Mojave. So this room, actually, you can see up there, it's an actual clean room, not right now.
Right.
You see all the filters at the top?
Yep,
So
yep.
when Haven-1 flight unit is ready, this will actually get turned into the integration room.
The integration
So when
room.
people will visit, you know, this will be control room area with 200 people, and then final integration will be occurring just right there, and then ship out.
And it's just right on the other side of the glass. I mean,
Yep.
mission control right here with the big screens, and then
So
Yeah, this is ready to go, basically, right? I think the
Well,
final weld was on it. I saw just a couple days ago.
yep.
It looked
So
like.
the next step is painting.
Yeah.
Then we're adding the window and the hatch, and then we're adding a few COPV mass simulator.
Yeah.
Ship out to our Mojave test stand, and it goes vertical, and then we will undergo pressure testing
Right.
and load testing. And so that's our qualification article. Right behind it, we're machining the panels for the flight one.
For the flight one. How'd you end up with the orthogrid on the outside instead of the inside? Was there a...
There was a trade. It was kind of a toss-up. It ended up being on the outside,
Okay.
mostly for mounting thermal control lines and so on. We
Right.
felt it would be better to have a smooth inside and the ribs on the outside.
And you
So-
can sort of see some of the mounting points included in some of the panels and
yeah,
stuff.
and these are, the final one have actually a lot more mounting points.
Yeah.
But yeah, that gives us a grid to have threads inside or outside to
Right.
mount the primary structure and so on.
But they're actually gonna like paint it. I mean, it's got painter's tape on it right now.
Yes, well, actually we won't paint. The reason it is painter's tape is
Yeah.
that the weld, we don't want to paint them.
You don't want to paint the welds.
So that through the campaign we can inspect them with various tools and do inspection after the pressure testing and so on.
After
So this is the end where the docking adapter from SpaceX
Right.
is mounted on that flange, and this is the top with a cap, and then you'll see the window on the side, on the other side when we get there.
I mean, the top end of it, is that pointy, for lack of a better term, just to maximize the space from the existing payload
it's
fairing?
basically the Falcon 9 fairing.
Yeah.
And you have blankets, you have various systems, and working with SpaceX, we want to use the full
The
volume.
full fairing.
And so it's also obviously you either have a dome at the end or a cone.
Yep, something.
You can't have a flat plate
'Cause it's a
on
pressure vessel.
vessel. So
Right.
you anyway need to reduce diameter and do that. But we went for this design to maximize the volume.
So you're making a space station that fits in the specific fairing so you can get it out there.
Well, of course, you
Yeah.
better have a fairing that fits into. Otherwise, no luck. All right, let's go down.
What was this area again?
Desks.
Desks.
It's about
just like-
200 desks. We have an astronaut lounge
Gotcha.
for meetings, and when our crew is here, we have a gym, we have a control room, and we have a lunch area in the middle, and then we have 200 desks for
Right.
some of our team. By the time we fly, VAST will be about 1,000 people, so we're still hiring at a really high rate right now. I'm being told we're still on track to move in first week of January.
First week of January.
Yeah.
It's the week before Christmas right now.
So it's 3 full weeks from today. I mean, the crew here is doing like insane work. And so from this window, you'll be able to look down.
Yeah.
And then from the platform behind as well.
This is like seating,
Seating.
like stadium seating, and then desk down
And then
here,
it's-
wall
and
of
then it's
screens.
flat, and then there's a whole gigantic curved LED screen that will be on there.
Yeah.
Yeah, it should be a pretty good and functional control room.
Yeah. But to come back and visit when it's done.
All right, now we're going to go to,
But wait, there's more.
well, we saw sort of it. but
Yeah.
we're going now in the primary structure area. So.
Max, I can't say thanks enough for letting us come out here and see all this.
I mean,
This is
we
amazing.
thank you for letting us show what we're doing to your audience,
Yeah.
which obviously we love. So,
I mean, so often we're in a situation where companies are like, oh, not everything's perfect. You can't see it yet. We're not ready. And here, you got stuff to do. Like
I mean,
you're
the-
building the building, you're building the parts, and you're letting us here see this.
what
This
we
is
love
amazing.
showing is a pace of progress. So,
Yeah.
come back in 6 months. We'll be in the middle of integration.
Yeah.
And that's what we love to show with our partners, whether it's SpaceX or,
Yep.
or NASA, with our future customers, space agencies from around the world.
Yeah.
And also our general supporters and followers. The more we can show, and also future team members, right?
Yep.
I'm sure a lot of engineers are looking at us right now. So check out our website, vastspace.com.
There you go.
Career button. So for all of these reasons, we love to build in public
Right.
and create trust and be transparent. So
I mean,
it's part of the
it
culture.
feels alive. It feels like you're doing things right now. It's not a bunch of renders on a screen or a PowerPoint. Like you're doing things. This is real hardware.
There's
This is
still a lot to do between now and a crew entering Haven-1.
Yeah.
But if you accelerate, if you're on the right track, it will happen.
Yeah.
So we'll take a break here so I can check
Okay.
which way we go. Give me
All
a
right.
minute.
We will hang out. y'all. I mean, like I said to Max, so often it's, oh, everything's not perfect. Oh, we don't want you to see this yet. And here, they have stuff to do. Like the mission control is under construction. There's space station hardware like in the next room over, or I guess the qual hardware right now technically is in the next room over. There's a diesel generator beeping at us. I don't know what that beeping is, but it's a real active environment. You compare this with, oh, everything's so prim and polished, and oh, we're not going to show you until everything's perfect. They're getting stuff done, and it feels so different. It feels new and exciting versus, oh yeah, here's this one little scrap we can show you. This is amazing. Now I want to go to space. I want to like be on the space station, like all these things. I want to work here almost. Don't worry, NSF, not going anywhere. But anyways.
It's lunch break, so a little quieter, but we can go around. So before we look at the primary structure, you know, we looked next door how raw material arrive.
Right.
We mill it into flat panels.
Right.
Like these one there. And then you can see them being rolled here. So these are the rollers we use with our, you know, master craft people that have a lot of experience. It's actually one part of the process that's more of an art than engineering to some extent. Oh. And we're talking about, you know, having a lot more panel than we need. So for example, these are all extra panels that were created for the qualification vehicle.
Right.
And we didn't end up needing them. But we wanted to be ready that if there was an issue making one of the ring, the first thing we do is we weld them all together into a ring that, you know, if there was a welding issue, an inspection issue, a scrap issue, we were ready to you know, weld another ring, you know, the next day.
Yeah.
So that's the advantage versus, you know, if you machine all of these things and form them out of house, it'll probably take you 6 to 8 months to get a new one.
Just the lead time.
And it takes us, well, first we have them on standby.
Yeah.
Even if we didn't have them on standby, it would take days for us to have a replacement if we needed to.
The rolling is such a specialized thing. Is there experience from another industry? Is it just aerospace people that know how to do this? Or
no, I mean,
who
pretty
needs
much,
to bend aluminum like this?
Pretty much, you know, a lot of pressure vessels and so on. And forming and rolling is, you know, there's many applications.
Right.
But people that have the aluminum experience with the ribs, it's a big thing, the specific diameter.
Yep.
Yeah, people in our team have more than individually 20 years of experience doing it for various applications, not obviously space station. So, you know, if you look at the history of space station primary structure, the ISS, many of them were built in the US by some of the prime in the late 90s and maybe early 2000s.
Right.
But it's been 20 years since a space station primary structure has been built in the US. Right now, most of all the new ones, including the Cygnus spacecraft, are built in Italy.
Right.
And so we're really proud that obviously the reason we are doing it is because we need to do it, low cost, high speed of iteration. But we're really proud to bring back that capability back to the United States that has not been here for a couple of decades. So this will be our primary structure final integration. If you look up, this is actual clean room filters. It doesn't have the white epoxy floor, but so when we're done with building the flight primary structure, this is the qualification primary structure.
Yeah.
We'll empty it, we'll put the white epoxy, we'll commission the clean room, and this is where the actual final integration of all the assembly will be, and then ship out through that door to Plumbrook, the NASA facility for vibe and thermal testing and TVAC, and then to the Cape for the launch campaign.
And so this qualification unit, the qual unit that you've made here, like the purpose of this is you're taking it out to Mojave and you're gonna pressurize it, you're gonna put load on it, you're gonna make sure that these structures as designed and maybe more importantly as built, right? Not just, oh, it worked in CAD, it should work here. You're actually able to make a real physical structure that can do that. That's where this thing is going.
And you qualify it. We actually will pressurize it more than the flight version.
Yep.
You can do something else called a protoqual where you put more pressure on the actual flight, but it's better to make two articles.
Right.
So that's what we're doing. We're doing a qual campaign and then a flight unit. Some of the key, on that side, you have obviously where the docking adapter and the flange will be for that, the IDA port for Dragon.
Yeah.
This side, you have a cap that will go right there at the end. The window is actually, I was hoping you could see it, but it's rolled right underneath.
It's rolled to the bottom.
We might be able to look inside there. All of these secondary structure are for the COPV.
Yep, you can see the mount point sort of around the edge there.
And then
that's why it's built that way, right?
One of the key elements, this is actually a piece of the test stand, so that's going to Mojave.
Okay.
And you see there's a flange right here.
Right.
this simulates the launch interface to the Falcon 9
the Falcon
path,
9.
where there is the 3.2 meter separation system.
Right.
And you can see, we can see this tape on it, but you can see a bit of it.
Sure.
That's the flange that will be sitting.
That it sort of sits in the middle of it. It carries the load, I guess, right?
So it's sitting upright.
Yep.
And it's mounted on the top of the payload adapter of SpaceX.
Yep.
With a separation system right there. So that's one of the key things you have to test, right? That it can handle all the loads and it's properly designed, because that's the only point where it's mounted during flight.
Being held by the rocket, right?
So the test that we do is, as we mentioned, pressure. So pressure, does it hold pressure? Does it leak?
Yeah.
Strain gauges and so on. We'll also do cycle pressure at the end of it.
Right.
And then the other thing, we have actuators on the test stand that are putting loads on it. It's pulling, it's pushing, so that it helps us simulate, the launch environment.
Right.
And then third, we also have mass simulator of all of the COPV tank. They're not mounted right here, but they will be there to create as much of a, as close as possible of a simulated environment
Right.
that it will see during ascent and in release. Basically.
I'm going to guess when this is all ready to go, the center of mass of it is shifted this way a little bit.
Well,
you got the tanks and everything. This is mostly
That's
empty space for the crew,
it's
right?
a good question. So the lower the CG, sort of the better for the launch.
Yep.
The lowest to the SEP system.
Right.
So that's why the propellant tank are there, not at the top. Right?
Yep. And it's right there where the adapter attaches to it, so the load is all concentrated down there. You're not transferring the load from the top all the way through the main structure down to the...
Yeah, and then at the top you have deflection, right?
It
And
wants
then you have the fairing interference. So that's all obviously designed for that purpose. Also, all the consumable, if you look at the render of the inside, the corridor, the most dense area,
Right.
where all of the
berths
water,
and
the
everything.
food, all of the propellant we discussed, it's all as low as possible.
Yep.
And then the common crew area, that's sort of
That open space.
and the open space is as forward as possible.
Yeah. Okay, you talked about the wet garbage containers we saw almost at the beginning.
Yep.
And they're exposed to the vacuum of space. How do they get from...
Oh, through a valve.
Through a valve.
And a tube that's
there's
on
a garbage
the outside.
valve.
Yeah, so when you seal it, we have, I forget the exact number, maybe 6.
Right.
When it's full at the end of one of the crewed mission,
Right.
they seal it, and then they open a valve, and then the vacuum gets in. Then they close the valve, and it's in vacuum.
It's in vacuum,
inside,
yeah.
Basically.
It lets, it's almost like a little airlock, but it's a trash can. It's
I
a
guess
trash
so.
lock or
And,
whatever.
obviously not having air means it's less likely to activate
rot
and
or
gases
off
and,
gas or whatever.
things like that. So
Like all the different things, you never think about that, right? If you like space stations, have you ever thought about how you deal with wet trash over long periods on a space station? That's a thing you have to solve
That's
if
how
you're
you do
making
it,
this.
yep.
So a trash airlock that just puts it in vacuum.
well, not an airlock, right? We're not. opening
Yeah,
it.
a trash lock.
Yeah, trash lock. A vacuum trash lock, we could call
Vacuum
it.
trash lock, yeah.
So yeah, we can try to get a sense. Yeah, we won't be able to see inside. They're working.
Yeah. And the ring
but
is for
this-
transport, right?
Yeah, it's a fixture. We actually are moving it right there for painting.
Okay.
So we'll be doing that in the next day.
Yeah.
And then the orifice you see there, that will be actually capped.
Right.
There is a cap that goes there at the end of integration. Everything that goes inside has to go through that opening.
Right.
And there's also the window opening, which is also 1.2 meter.
Yep.
So and then the hatch opening. So we have 3 openings to bring all the secondary structure, the shelves,
Right.
everything, the avionics, everything through, and then obviously we close it out.
Is this hole bigger than the other end with the hatch? Like, can you get larger things, or is it the same size?
I believe that's the largest.
And then you get everything inside of it, then you cap this off, because
Yep.
this is just pressure vessel at the end of the day, right? So you have this, and you sort of load everything into your apartment, for lack of a better term, right? And you close this off, so you're done with it. And then you don't have to move as much stuff. It's more consumables and things from the other end of the hatch end.
Well, no, consumable, it's interesting with the Dragon payload.
Right.
You could only bring consumable for a few days.
Right.
So if you're talking about 40 days, the consumable are not coming from Dragon. They are meeting the crew there.
They're
Of
meeting
course,
the
they'll-
crew there.
They'll bring some fresh food and things like that. But the oxygen, the water, the all of the CO2 scrubbing filters,
Yep.
all of that really high mass, high volume consumable, they are launching on the Falcon 9.
Here
not
with the station,
with the
like it's already
They are
stocked.
not going on the Dragon.
Gotcha.
Otherwise, it doesn't work. You can't bring enough to stay 2 weeks or more, basically.
And I guess with this, you can't really use the cargo area in the back of the Dragon, the open part of the trunk. There's not really anything you can put in there because there's not a way currently to get it into the station.
Correct. And I don't think, other than the Starlink laser for Polaris Dawn, I don't think they use the trunk for crew mission.
These sorts of things. Yeah,
They use it
exactly.
for cargo mission, and you need a robotic arm, which
To
we don't
extract it from the
Yes.
trunk or something.
Haven-2 will have this capability, not
Yep.
Haven-1.
Yeah, this is to get started the single module. And I can't get over the fact that it's just designed to fit in the fairing. Even the way that it tapers at the back so
Yeah.
you can put the tanks on the outside, like the whole thing, you can just see it's designed to fit.
Yeah, and by volume, it will be the largest payload that ever
Payload that's
launched
been-
on a Falcon 9.
Okay.
If you think of it as a satellite, 14 ton,
Yep.
this volume, it's a very large space object.
Yep.
Even though it's a small space station,
It's a large space, single object.
So the next one, actually, let's go on the side.
Yeah.
We could do one more.
I want to see the solar panels where the solar panels mount too.
You
are
won't
bound to
see
be.
they mount to the outside
Right.
skin, but you won't see it. And we talked about the MMOD shielding, right?
Yep.
That will be there. But the other piece there is that if you think about, we've designed all the tooling, everything to make 3.8 meter diameter, 2.8 meter to cone down to the docking adapter to a Dragon to cap it off. Now for the Haven-2, what we're really doing is we're having this part on the other side too, right? You
Okay.
can see it's not going to be very complicated
Yep.
to put another docking adapter there.
Yep,
from
it's
a
just
primary
designed that
structure.
way, yeah.
Yeah, it's a bit of a different taper, but
Sure.
and then we are making it 5 meter longer. So how are we going to do that? By adding 2 rings. So this facility is designed to make the larger one. The tooling is designed to make the larger one.
Yep.
And the process will be exactly the same. So you can see how much Haven-1 is getting us much closer to Haven-2,
Haven-2.
which goes on a Falcon Heavy with the new stretch fairing.
Stretch fairing because you're
That's-
adding in the ring, so then you have to stretch the fairing
Exactly.
too.
But the other advantage is we can go from 14 ton to 28 ton,
Right.
double the mass. And we can go from 120 days, full crew, 40 days, so 120 days.
Yep.
160 days of consumable. We go from that to 720 days because we have so much volume.
Yep.
And one of the things we do, and then the usable volume goes 2x by adding the 5 meter.
Right.
And the advantage is that one of our architecture is that we believe that the nations should really make sure, the US should really make sure we have a space station on orbit in 2028.
Right.
Well before the
Before
ISS.
the ISS.
So you have 2 years to test it.
We don't want the shuttle problem again.
Exactly. We also believe that it should not be permanently crewed on day one, so that you can have a simpler life support system
Yep.
using consumable. And then we should, the winner of the competition, should try to improve the life support system towards a closed loop, recycle everything, better CO2 scrubbing, recycle the water
Right.
as quickly as you can, so that you can have it permanently crewed
Yep.
as quickly as you can. The current procurement process says that it has to be permanently crewed on day one. It's never occurred on any space station, including the ISS.
Right.
And we believe that all that will do is that will just delay having anything up there. So something that can be temporarily crewed, crew tended,
Yep.
maybe a 2 90-day mission or 2 60-day mission with using consumables, which we will have proven with Haven-1.
Yep.
And then we're adding module 2, module 3, module 4 every 6 months. That's our architecture.
Like expanding it and
And-
attaching them all together, I
Well,
guess.
each extra module are bringing more consumable,
Right.
but also our goal is that each module is bringing better technology,
Right.
but we don't have to have it to have a crew there.
Right.
So by the time we're done in 2030 with the first 4 modules, we expect that we will have an efficient life support system,
Right.
but we will have already used it for 2 years before that. So that's one of our key strategies that differentiate us. A lot of our competitors are, to be honest, pretending that yes, we can have it permanently crewed on day one.
Right.
And we just don't think that's realistic.
It doesn't make sense.
There's no precedent of it,
Right.
basically. So
Oh, no kidding. I mean, it seems so interesting. I'm curious, when you get to Haven-2, are there different internal designs for modules, right?
Well,
or are they all the same?
well, we
Are they
have
different?
an interesting approach, right? If you look at the ISS, you have power module, you have experiment module, you have.
Yep.
So our approach is more of a platform where
Right.
every module can dock itself. So it's Think
It's
of
got
it as like a
propulsion.
Dragon capability.
Yep.
So they can dock autonomously to each other, and every module can live by itself as a free flyer.
Right.
Right. That's the basic of the design, which is very different than the ISS. And it's also, if we have an anomaly on a module, we could get rid of it without compromising
Without the
whole
entire
station.
station. Right.
And it's just a more interesting architecture. We can also be fully functional with the first module and so on. It's also lower cost because we have one design.
One
We just
design. It's
came-
like, here's the vessel, here's the size, the shape. It's almost a bus, right? The space station
it's a
bus, like
platform,
a
it's
satellite
bus.
bus.
So it has, all the same basics and all independent. Now, when it comes to outfitting, right now on Haven-1 we have 4 sleeping berths.
Right.
We have, a set of life support system. We have a set of payload capability. So the platform will be the same. The outfitting and the use of the space,
Yep.
we expect it to be different on each. Right?
Sure.
They will all have a little difference. Maybe, module 1 will have 4 sleeping berths. Module 2 will have 4. That's 8. Maybe we'll decide that's enough.
Right.
Module 3 will not have any sleeping berth, and we will use that for something else.
Extra
right?
storage or whatever, and you can start customizing it. But I love the idea of the basic unit. Like,
Is the
hey,
same.
this thing can fly on its own. You can have this +1, +2, +3, +4, and you sort of build it out. Is Haven 2 one structure? Will there be Haven 2.1, 2.2, or is Haven 2?
Well, Haven 2 is our proposed design for
Yep.
the ISS replacement and our
Yep.
strategy. The exact design will be based on their requirements
Sure.
that they put out there. So right now it's 4 modules that are 3.8 meter diameter Falcon Heavy stretch fairing.
Yep.
And then there's a core module that's a 7 meter diameter that will be launched on Starship.
Right.
And then 4 more 3.8 meter module.
Okay.
And so that's our full capability, fully built in 2032. And our view is that there should be no gap, there should be an overlap, and it doesn't matter. You cannot on day one have this, all the capabilities of the ISS.
Right.
So we believe that a concept like Haven 2, first, it needs to be there, it needs to exist in 2028,
Right.
but it also needs to be able to grow to something that's more capable, lower cost than the ISS, and also Tiangong and any other competing
Sure.
countries.
The governmental, like, country space stations or international space stations for the ISS, like, this is a different thing than those.
Well, it's definitely lower cost
Sure.
and commercial, and it's not fully owned by the government, and it's on a fixed firm price contract, and will be a
Right,
lot
right.
cheaper to the taxpayer. But the point is that the vision for the ISS replacement, the ISS was built designed, 4 decades ago, and launched, more than 2 decades ago.
Yep.
We are now a new generation of people, of spacefaring engineers, and
Technology,
so on.
everything.
We can't aim at something less capable and less exciting. We have to do something better.
Yep.
So that's our strategy, right? It starts simpler, but then it can evolve to something
Right.
far more capable, and it should include EVA capability. It should include more power, more payload rack. It should include more volume. It should be much lower cost, much
Yep.
easier to maintain. That's our vision for Haven 2, and that's what the design is offering, right? Start small, fast, but yet don't aim at something less exciting than the ISS.
Right. For the EVA, is it a extra airlock module
It will
that
be
you
in the
put
core
on
module,
it?
the 7 meter
It'd be a
module.
core module.
Yeah. And
Gotcha.
then, talking about Starship, we wish we could launch all of the Haven 2 module on Starship.
Right.
We don't yet know the exact, volume of the Starship fairing, and we don't know yet the mechanism.
Yep. How does it
And
get in and out? All
And as
these
we know,
things.
SpaceX is focused on what they should be focused on is making money to get to Mars, which is a Starlink
Yep.
use of Starship and the reusability. So the reason we are not starting with 7 meter is not because we don't believe Starship will be ready. I think they'll be launching, whatever they call the Starship Starlink. It's not
Sure.
V2, whatever, V3,
yeah.
whatever is the name. They'll be doing that next year.
Right.
And if they wanted to, they probably could launch a space station on Starship probably next year or the year after.
Right.
But so they'll be ready, but we have to be ready to make 7 meter structure. That's not a trivial, you can see the amount of tooling in the space. This is 3.8 meter.
Yep.
It will take us time to first earn our stripes making 3.8 meter
Yeah.
to prove that in space before we can create a team that would have to be either on the port of Long Beach or at the Cape, because 7 meter structure, you cannot move them around
On roads. Yep.
So at some point we will kick off a separate team that will make 7 meter structure that will be designed to take advantage of the Starship diameter and volume.
Right.
But we first need to get this down, right?
I don't think the doors are big enough. I'm looking at the
we
doors
cannot
and
do
I'm
this
like,
here. Everything will be, you've seen Starbase, so you've been Starbase.
Yep.
A whole different scale.
A whole different
so
scale.
The point is that that's why we're not starting with it, and we think that's the right strategy. And then eventually we'll get there, and that's first the core module, which we want to launch in 2030.
Yep.
And we hope we'll launch them all on Starship, but right now we know for sure we can launch them all of these ones on
Because
Falcon Heavy, because
this
it
exists.
exists.
Falcon 9 flies a lot. You know exactly how big the payload fairing is. You can design for that. The stretch fairing is a lot different than engineering an entire new vehicle, right? So getting the additional volume from stretching the fairing
back
a
to
bit.
the, adapting to the launch vehicle with that subsystem, it all exists.
Yep.
For Starship, we don't know yet.
So you
how
design
can we
for things
it?
that exist, like you do that, but you can do this so quickly. When those things get figured out, then your team with the experience and all your processes and everything, you can start building those things.
Yeah, our view is that what we have to prove is that we can build a safe, functional space station.
Yep.
Right? Prove to ourselves, prove to the world, prove to NASA, and that can be visited by a crew that can come home safely.
Yep.
That's going from 0 to 1. Once we're there, I'm pretty sure everybody will trust us. With money and time, we can build bigger.
Right.
Like, that's not the hard piece. That just takes time and money to go from 3.8 meter to go to 7.
Yep.
What's hard is to have all the skills from avionics, thermal, primary structure, all of the process, all of the tool that you can create the system and launch it. And that's the biggest difficulty.
Right.
Once we earn that stripe and that proof point, I think we can build anything. It's just a question of time and money.
It's like the sky's the limit, but it's not actually the limit because you're going to space. All right, we've seen so much here. You've taken us all over the factory. This is getting ready to go Mojave. In fact, by the time the video's done, we may have some results of that.
Yep.
Because it's probably going to beat the video being edited. You're going to get this to Mojave before we get the video edited. But Max, this is amazing. Thank you so much.
This is all the team that we have, and it's incredible how, as we make progress, as we share it, including this video, which is super helpful to us, how many more incredibly talented engineers that either have had experience working on crew program or new graduates are applying, and without the team and the skills in the team, we can't do any of it. So thanks for being here and help us tell our story to keep attracting amazing engineers to hopefully join us soon.
Folks, Max knows his stuff, and I guarantee you that somebody like that attracts other people who want to get stuff done. We got to walk around their factory where they're actually making space station hardware. It feels alive. It gives me hope that we're actually going to end up living and working in space one day. Massive thanks to Max and the rest of the team at VAST for inviting us here and giving us this access to their facility. We're going to keep up with VAST to see what they're able to accomplish here. And if you want some more behind the scenes content and stuff like that, make sure you check out the member program or just like and subscribe to the channel here. I'm John Galloway for NSF. This is what we do, and we'll see you nerds later.